Topic 15.4 is about a set of special materials. It follows straight on from polymers. Polymers are obviously a set of special materials which are used widely in modern life. Glass, ceramic and composites are different materials again. Glass is made slightly unexpectedly from sand, which is mostly silicon dioxide. They then add soda, as it used to be called, sodium carbonate, and lime, as it used to be called, limestone, all mixed together, heated to about 1500 degrees. At which point the materials all melt and combine, and then cooled. Of course, we all know what glass looks like. It is sometimes called soda lime glass because of the sodium carbonate and the limestone or calcium carbonate, and it has the kind of properties that we know of glass. It's amazingly see-through. It's very helpful. It's also rigid, and of course, when hit by footballs, a bit brittle. The interesting thing to note, and I haven't got a diagram here to show, but there'll be one on the board or in the internet if you go and look, is that the molecular structure, if you look at the individual silicon and oxygen particles, is irregular. So it's got an irregular pattern of atoms in it, unlike something, say, like diamond or graphite, which has very regular, organized lattice of particles, atoms, joined by covalent bonds. In glass, it's pretty irregular. Okay, ceramics then. Oh, sorry. Just before I do ceramics, just mention borosilicate glass, where they add boron oxide, makes the glass resistant to high temperatures. So whenever you're using glass in the kitchen, if you've got one of those glass jugs you can pour boiling water to, or a glass tray you can put your lasagna in and put it in the oven, it'll be made of borosilicate glass. The boron oxide enables it to resist the high temperatures. Used in kitchens and laboratories. Okay. Ceramics, on the other hand, are made from, of course, clay. Heated in a kiln to pretty high temperatures again, usually over 1000 degrees. What's called firing the clay, because originally they would have used fire. So we're talking about a material that's used to make, well, mugs stuff. China, what we refer to as China, is really ceramic, and also hard products like your sink, your bathroom sink, toilet is almost certainly made from ceramic. They tend not to stain. They're very easy to clean, or easy to see when they're dirty. But like glass, can be a little bit brittle. Again, it takes a bit more welly to break ceramic. The reason is it's made up of a mixture of ionic and covalent bonds in the structure, and it's a much more regular structure. And that can mean if you just hit it with a hammer or something, the lattice gets distorted, and you can have, rather than negative with positive, you can have positive lining up with positive and negative lining up with negative, and that, sorry, that's the wrong way. That causes the the structure to split. So unlike glass, ceramics have a much more regular structure. What happens? Well, clay is clay's sort of slippery. I don't know if you've ever handled clay, but it's quite satisfying to sort of move through your hands and squeeze, and it goes through your fingers. Clay contains a lot of water. It's usually kept in water, and that gets between the layers, and that's what makes it so slippery. Those layers can slide over each other. We've heard that before, haven't we? When it's heated, that drives the water out, and so the layers then stick to each other, making that hard, robust, rigid material. And lastly, composite materials. Composite just means it's made from more than one type of material, right? So I think about a like a Gore-Tex coat. It's got a layer of special polymer on the outside called PTFE, polytetrafluoroethene, on the outside, and then that's built over a layer of nylon and so on. So these layers are meshed together, and what that does is gives the composite product the properties of all the different materials that have been put into it. So so we have two or more materials that are combined to provide, well, some special properties is how I'll phrase it. Special properties depends on the material that we're looking at, right? So a good example of that would be fiberglass. Fiberglass is well, it's glass or a ceramic. So we have long thin pieces of glass mixed together with a polymer resin. So a glass or a ceramic plus a polymer resin, and then you can make that into the shape of whatever it is you want to make. You build it into something. It's got it's hard to describe it really. It's sort of a sticky, movable. It's a bit like working with, I don't know, it's got a gluey consistency, but it sets hard like any polymer does. But the material you get kind of has the benefits of both the ceramic and the polymer. So it's hard, it's tough, it's lightweight, it's flexible, waterproof. You think about a canoe. Okay, you imagine a canoe. So this tough, well, it's not plastic material. I mean, they could be made of plastic, but fiberglass is tougher than plastics. Plastics get old and they tend to split, crack, and so on, whereas fiberglass is much more long-lasting. There are other examples. If you're in the tech department, again, you might have come across MDF, the medium density fiberboard. It's basically bits of wood shavings all kind of glued together, and it makes a material that, unlike wood, won't sort of split. Wood splits down the grain, doesn't it? Whereas MDF won't split. I just want to finish with concrete. I mean, concrete's an amazing material, invented by the Romans. Believe it or not, there are still concrete buildings around the Pantheon in Rome, and it's made from cement, which is material. Well, it's made from lime and clay, water, and then sand or gravel is thrown in. and it's a kind of an amazing material because it's sort of synthetic stone. You can pour it, you can carry it around in a lorry, it can come out in a tube, and you can squeeze it, you can build it into buildings, you can pump it up, hundreds of feet above the ground, and then when it sets, it's as hard as rock. So again, it's sort of rigid, robust, can be a bit brittle, so we make reinforced concrete. This is the composite aspect of the concrete. We make reinforced concrete by adding steel bars, reinforcing steel bars, sometimes called rebar. So the way this is, and you'll see this on building sites, they put out the steel mesh on the ground or upright, and then they fill a mould with concrete, and the steel adds flexibility to the concrete, which makes it an almost indestructible material. So think about your skyscrapers, the Burj Khalifa. You're talking about a building which is thousands of feet high. It's just held up by cement, water, sand, and rebar. It's an incredible material. Okay, thank you very much.